All right. This is Chapter 2, Section 8. It's called Literal Equations and Dimensional Analysis. Sounds super fancy. We're going to break it down so that, we can figure out what those two terms mean. So before we get started on that, just kind of go through the screen here like I do in all the other videos. So this will be what it looks like when you open your screen, your homework screen, with the exception of two things. The first thing is that you will see a due date here. I don't get a due date on the teacher preview. It just doesn't give me that because it's not actually due for me. It's due for you as a student. Attempts, it does show you this. So this is my first attempt of unlimited attempts. I can come in and do this as many times as I would like. And this has to do with submitting the assignment. We'll get to submitting in just a second. Number of questions, this one has 10 questions. It will have anywhere from 1 to 10 questions on any of your homework assignments. So 10 is the most it can have. Grading policy is best score, meaning whichever attempt is your best one is the one you get to keep. And partial credit is enabled, meaning if you answer 1 of 10 questions, you get to keep the credit for that one question. This is a reminder that you should always submit your homework. So once you click start here, this is the second thing that will be different on your screen. You will see a submit assignment button at the bottom here. You always want to make sure when you're done, you're working on the assignment, even if you're not completely done, once you're leaving the assignment, you click the submit assignment button. So whether or not you've answered a single question or you've answered 1 of 10 or 10 of 10, doesn't matter how many you've answered, you click submit assignment. Number 1, that shows us you were in the assignment, how many you've answered, what percentage you're getting. It also stops the system from locking you out of all of your other assignments. If you just leave the screen, so if you exit out of the screen or you click on the little menu and you go to home, it will let you leave, but then it will lock everything else. You can't do topics, you can't do other homework assignments, quizzes, tests, you can't do anything until you come back into this assignment and click submit button. So it's just a very good practice to get into. Just always click that submit button when you're ready to leave. Remember, unlimited retakes. So you get to come back in and take it again and again and again. Doesn't matter how many times you hit that submit button. All right. You'll also see these 3 tools on the side. So we have explanation. This is going to explain this exact question you're looking at. So it's not going to explain it to you and then, give you the answer and say, okay, go type that answer in. You're going to lose your question attempt because it's giving you the answer. But it's a very cool feature because maybe the example is slightly different and you want to see how this one is done. But the example usually is pretty good. It will give you something very similar to what you're doing. So we have a conversion problem here. We have our table that helps us convert, and then it'll explain to us what we're doing. It even gives us a little example here with a picture, and then it shows us how to type the answer in. So once we're done, we can just close the example. You can open it for another one. If you want another example, it'll be a different example in here when I open it up. Oh, it looked very similar. I think the numbers were different. I hope they were. It's supposed to be a different example anyway. Message center. That way you can click here and it'll create a message to send to your teacher. It'll attach this exact problem to your message so we know where to help you. All right, let's go ahead and get started here. So we have, on a long hike, Ashley drank 8 pints of water. How much is this in quarts? So we're going from pints to quarts. That's what we want to do here. So we have 8 pints, and we want to know how many quarts that's going to be. So we want to figure this out. Well, we need to look at our conversion table that they gave us here. It says use the table below, include the correct unit in your answer. So we're going to have to click on this on the screen. So if I go down here, I have pint, and on here it goes pint to cups, or I can go quart to cup to pints. So with this one, I have 1 quart equals 2 pints. So this is my conversion. This is what I know. It's kind of going a little bit backwards, but I could also do 2 pints equals 1 quart like this. So when they're on the same side, because I have pints, what I want to do is I want to divide that. If they were on opposite sides, then I would multiply. So since they're on the same side, I'm going to divide, and I'm going to go, okay, 8 pints. For every 2 of them, that's 1 cup. Or sorry, 1 quart. I'm just losing my mind. So 8 divided by 2, that's 4 quarts. And you just do QT for the abbreviation there. And pints is PTS. or just PT. Sometimes there's an S, sometimes there isn't there. I tend to put an S on my pints for whatever reason. So we're going to go ahead and go 4. And we need to make sure we include the unit. And this is actually the part of dimensional analysis. So this is what dimensional analysis means, is I'm carrying my units through the problem. And my answer at the end will have a unit. It gives it meaning. It's not just 4 of something, for, cats or dogs or horses. It's for quarts. I'm identifying the meaning of the number. So that's what dimensional analysis means. It sounds really, really fancy, but all it means is give your answer units. So you started your problem with units and you're ending it with some kind of unit. All right. Continue. I'm just going to go new. New. Don't save. Okay. So Dr. Simmons just started an experiment. He will collect data for 9 days. How many hours is this? So if we're looking at this and we have days and we want to go to hours, well, they haven't given us a conversion, have they? They're assuming we know this conversion. This one should be pretty well known at this point in our lives, right? 1 day equals how many hours? Well, 24 hours, right? Hopefully everybody knows that conversion. And I know one of the ones I did in class was hours to minutes. And again, they didn't give us the conversion. They're just assuming we know this. Because this is time, and we use this, all the time, every single day, all week long, all year long. So if we have 9 days and we want to know how many hours that is, these are on opposite sides, right? That's what I was talking about. If they're on the same side, and I'm not talking about the 1, I'm talking about the other numbers. If they're on the same side, we divide. But if they're on opposite sides, then we multiply. So it's 9 times 24. And for whatever reason, they're not giving you a calculator here, so you can write it off to the side if you need to, but you're welcome to use a calculator. You can go 9 times 24, 24 times 9, and we get 216. Okay, so we get 216, and that's 216 hours. They already wrote hours there for us, so we just have to put the number in there. All right, and I believe, I'm going to click on it really quick, they probably will give you the conversion here. So they do give you a conversion here on the explanation if you need it. Okay. All right, continue. And I'm just going to really big, so I can just erase that really quick. I don't have to keep hitting new. So an apartment has 810 square feet of carpeting. How much is this in square meters? All right, so we're going from square feet to square meters. So this is our conversion here. And use the following conversion. 1 square meter is 10.8 square feet. So 1 square meter is 8.10 square feet. So make sure you put it in the right order there. I put square feet to square meters. So I need to make sure it's 1 square meter to square feet. So I have to make sure I put it backwards kind of when I write it down there, because that's the way it works. Or that's the way they gave it to me. And then they say, it's 110 square feet of carpeting. So he has 110 square feet. And we want to know how many meters that is. So be careful when you divide this, because I don't want to do 8.10 divided by 810. I want to divide what is my total, what do I have, divided by the conversion there. So for every 8.1 square feet, it equals 1 meter. I just need to figure out how many 8.1s are in 810. So this would be 100. And hopefully we can see that. It's 8.1, it's 8.1. It's just moving over the decimal there by 2. So if I go 1, 2, okay, well, that's 100. Not sure if everybody necessarily sees that right away, but that's the conversion there would be to 100. So we have 100 square meters. Check. Uh-oh, what happened? Oh, why did I type silly me? It was supposed to be 10.8. I don't know why I typed in 8.1, because I'm just losing my mind here. So let's try that one again. It's 810 divided by 10.8. I don't know why I wrote that backwards. Being a little dyslexic there with writing my numbers backwards. Instead of 10.8, I wrote 8.1. All right, so 75 square meters, not 100. So at least the nice thing here is that Alex does give you a chance to try again. It doesn't just say automatically you're wrong. You don't get to try that one again. You get to recheck it and say, okay, yay, you're right this time. It was just an oops. So it gives you a chance to go back and look at your work and say, uh-oh, where did I go wrong? All right, next one here. Okay, so this is where we're getting into literal equations. So again, sounds really fancy. What it means is it's an equation that involves mostly letters or variables. Formulas are a very common thing to be in literal equations, and we call them literal because they literally stand for something. So usually, and I can give you an example, if we have a volume formula, we would have V, capital V stands for volume, and I can do like the volume of, like say, a box shape, a prism, a rectangular prism in particular. We have length times width times height. Well, this is all letters, right? They're all variables, but they all stand for a literal part of the box or the rectangular prism, right? This is the length of it, this is the width, this is the height. They're not just kind of random variables, they have a very literal meaning. So that's why we call it literal equations. So in this one, what we're going to do is we're going to take our equations that they give us, and it's going to ask us to solve, and I'm going to put little lines on here because my S's look like 5s, or at least that's what students tell me all the time. So we have our equation here, P equals R plus S minus 8, and they want us to solve for R, which means we need to get R all by itself. Even though we don't know what P is, we don't know what S is, we want to get R by itself just like we would if R was the only variable. So we're going to take our pieces and we're going to move them away from R. So I'm going to look at this one right next to it. I'm adding S, so I'm going to subtract S from both sides. So I'm going to have P minus S equals R. S minus S cancels out, minus 8. All right, we have one more piece to move. I have to go plus 8, plus 8. So I have P minus S plus 8 equals R. 8 minus 8 cancels out. R is by itself. I have solved for R. It doesn't matter that we have R equals on the screen and we have equals R over here. It's okay. That's a symmetric property. We can flip that around. But remember, we can't combine P, S, and 8. P and S are different variables, and 8 is a constant. So we can't combine them. We don't know what they are. We just have to keep them as separate terms. So we have capital P minus lowercase s plus 8. I would also be careful on capitals and lowercase. Don't change those because a lot of the time in a formula, capital means something different than lowercase. You might actually have both things in there. For example, if I have, let's see, the volume of a triangular prism, I might have 1/2 base times height times the height, like this. And so 1 is the height of the rectangle or the triangle, like this, and then 1 is the height of the actual prism if we were to draw this. So this would be the height of the entire prism, and this small h would be the height of the triangle. So be very, very careful about switching your capitals, okay? Because that will change your answer on some of those. All right, don't save, continue. Okay, so we have h equals a divided by 8, and it wants us to solve for a. I want to get a all by itself. So I'm going to say what's being done to a, the variable a there, and I'm going to do the opposite. There's only one thing being done to it. It's being divided by 8. So I'm going to multiply by 8 on both sides, just like I would if this was any other equation. And so I have 8 times h, which is just 8h. 8 divided by 8 cancels, and I have a. So I have solved for a. Again, I know a is on the right side instead of the left side, but that's a symmetric property. It makes no difference at all. You still have a equals 8h or 8h equals a. All I'm doing is flipping them around. It's like I'm mirroring them. Okay. Next. All right, we have k equals 16yz. All right, now we're getting a little bit more involved. I'm going to cross my z there so you don't think it's a 2. We want to solve for y. So I'm going to say, what's being done to the y? Well, I'm doing two things. I'm multiplying by 16 and I'm multiplying by z. So I want to divide by both 16 and z. And you can do this at the same time. You can do it one at a time if you want, but you can do it at the same time. We can move them both. So 16 divided, or k divided by 16z. So we can't do anything with this really. It needs to stay exactly that way because I don't know what k is, I don't know what z is, so there's no combination there. But 16 divided by 16 cancels, z divided by z cancels, and y is left all by itself. So now I can say that it equals k, capital K, divided by 16 lowercase z. Again, be careful on that. Don't flip your capitals and your lowercase. In fact, I'm just going to go ahead and try it and see what Alex does. So it gave it to me, but it's giving me that warning. You're correct. However, you may have confused the upper and lowercase letters. So it's definitely giving me that warning, the same one I've been giving you. Be careful, because once we get into using formulas, uppercase and lowercase do matter, because they might represent different things. So it did let me put it in, at least. It just didn't, it didn't like it. It warned me against it. All right. Okay, so now we have k equals 3r minus s, and we're going to solve for r. So now we say what's being done to the variable. I'm multiplying it by 3, and I'm subtracting s. So just like I would on any other equation, I want to do addition and subtraction first. So I'm going to look at that subtracting s, and I'm going to add s to both sides. Okay, and so I have k plus s equals 3r. The s minus s, those cancel out. So now I can deal with this divide by 3. We're multiplying by 3, so that's why I'm saying deal with the dividing by 3 here. So I'm going to divide by 3. So k plus s divided by 3, the whole thing gets divided by 3. And 3 divided by 3 cancels out, so this equals r. So I'm just being a little lazy and not rewriting the whole thing because it's exactly this, just without the 3's. So now I'm going to go k plus s, and make sure it's capital K plus lowercase s. And now I didn't hit the fraction bar to begin with, so I want to make sure if I hit the fraction bar now, it's only going to be the s over the fraction. But if I highlight the whole thing here, then it'll put the whole thing in the fraction for me. If I were to hit the fraction bar to begin with and start typing it in, I don't have to worry about that highlighting part. So just be careful when you're using the tools there. You want to make sure it's the whole thing, k plus s, divided by 3. All right, a couple more here. We're getting there. Okay, so z equals 2 times x minus 2. So we want to solve for x, this guy. So we need to simplify this. And because I don't really want to distribute this, because I don't want to add anything or put any more onto the x that I'm going to have to move, instead of distributing the 2 like I normally would, I'm actually going to do this divide by 2 step. So this is a 2. See, my 2's and my z's look a lot alike. That's why I cross my z's. So you know that they're z's and not 2's. So we have z divided by 2. I can't really do anything about that. We're just going to leave it. Z divided by 2 equals, well, 2 divided by 2 cancels out. So I just have x minus 2. So now all I have to do to get x by itself is do the opposite of this addition that's happened, or the subtraction, by adding 2 to both sides. So now I have z divided by 2 plus 2. And that just gets tacked on over here. It's not on top of the fraction. Okay, only z is being divided by 2. And these 2's cancel out because negative 2 plus 2 is 0. So now I have z divided by 2 and plus 2. Make sure you move out of the fraction for the plus 2. That's just getting added after we divide z by 2. Then we're going to add 2 to that. Okay? All right. So now we're getting a little bit more complicated as we go along here, just because they're giving us a little bit more each time. H minus k. So we're going to solve for h here. So again, I would not distribute this 1/9. What I would do is I would say, okay, this actually means I'm dividing by 9. Because remember, that's what a fraction means. I'm multiplying by the top, dividing by the bottom. So if I multiply by 1, that doesn't change anything. But if I divide by 9, that does change everything, right? That makes it 1/9 of what it is. But what I can do is I can multiply both sides by 9. Because I'm multiplying by 9, I'm dividing by 9. Those cancel out. So just like dividing by that number that's in front, I can do the same thing for a fraction and multiply by that number. If it wasn't just 1/9, if it was actually, a number like maybe 2/3, I would want to multiply by the reciprocal, which means you flip it over. Okay? And that just helps get rid of the fraction there. So on this side, I have 9f equals g plus h minus k, because remember, this 1/9 times 9 cancels out, because it's 9 times 1, so this would actually give me 9 over 9 if I think of it that way. If I did 9 times 1, it would have 9 on the top, and I have 9 on the bottom. Because technically, there's 1 on the bottom here. Okay, so that's why they cancel out that way. It's 9 divided by 9. All right, so we're still trying to get h by itself. So now I'm going to look what else is being done to the h. Well, I'm adding g, so I can subtract g from both sides. I'm also subtracting k, and I could do this in the same step if I want. I can say, well, I'm going to add k in the same step to both sides. And that's perfectly fine. If that's confusing at all, please go back, slow down, and do it one step at a time, where you subtract g from both sides, and then in your next steps, add k. So g minus g cancels, negative k plus k, those cancel, and I have just h drop down here. So you can do multiple steps at a time, but if you're getting confused, and just be aware, depending on your teacher, they may ask you to write out each step, especially if they see that you're getting confused or making mistakes there. They may ask you, okay, slow down. Let's go back and do a step at a time until we understand this a little better. Okay? All right, we're going to check that guy, and we have one more to do here. We'll be all done with this assignment. All right, so as Mars revolves around the sun, it travels at a rate of approximately 15 miles per second. Convert this rate to miles per minute. At this rate, how many miles will Mars travel in 3 minutes? Do not round your answer. So this one's a little different because now we're dealing with a ratio. So it travels at approximately 15 miles per 1 second. I'm just going to write sec there. And we want to convert this from miles per 2 miles per minute. So we want to change this to miles per minute. Okay? So what that means is if for every second it's going 15 miles, well, how many seconds are in a minute? Well, there's 60, right? So I'm going to multiply by 60 to get there. So I need to do the same thing on the top here. I'm going to multiply by 60. So 15 times 60 is 900. So every minute it's going to go 900 miles. That's how fast it's revolving around the sun. Okay? That sounds really, really fast. It's, on a planetary scale, that's, not terribly crazy. For us, 900 miles in 1 minute, that sounds like a whole lot, right? So, sorry, I wrote 60 here. We're multiplying by 60. It's 1 minute. But we're multiplying by 60 because it's 60 seconds. I want to make that clear. So, if now it's saying, okay, we're going 900 miles per minute. So that was our first piece. Now it says how far does it travel in 3 minutes? Well, if it's 900 miles per minute, for every single minute it's going 900 miles, we can just take the 900 and say, okay, I'm going to multiply that by the number of minutes it gives me. In this case, it's 3. So you can go back to your calculator, and it tends to save, what you put in there last, times 3. So I'm going to go 2,700 miles, or 2,700, depending on how you want to say that. All right, we're going to go and check that, and we're good to go there. So we just want to kind of think about this conversion when we're doing this. So it's giving us this kind of basic ratio, 15 miles per 1 second, and I need to convert it to miles per minute. So it depends on the conversion there, And if you click on here, I believe it'll give you the conversion table again. It doesn't give you the conversion table necessarily in here. So you may have to look it up if it gives you kind of a different conversion that you're not sure how to go from one to the other. You may have to look that up. We have the internet as a resource there, so we can look it up if we need to. But hopefully they give you one that, you know, is a kind of an easy conversion to make, or they will tell you. If they're asking you like from miles to kilometers, they're usually going to tell you what that conversion is. But all right, well, that was section 8, and I will see you in section 9.